Hello and welcome to the second lesson in your exponent and log unit. This should be review from this all the way back to Math 1 and probably in Math 2 and Math 3, but looking back at exponential decay, exponential growth, compound interest, and compounding continuously. That might be new, but not very hard. So, the big difference in growth and decay, of course, A is the amount that you're going to end up with at the end. P is the principal, the amount you put in, what you start with. 1 minus, because it's decay, you're going to subtract the rate. It's important that you, and it's all explained down here, the rate's going to be given as a percentage, and you're going to change that to a decimal. Then that's to the t power, which is the time, and it's important that that time matches that rate. So if the rate is per year, your time will be in years. If your rate is per week, your time is in weeks. If your rate is per day, time is in days. Growth is the same thing. What you P put in, right? A is the amount you get at the end. R is your rate as a decimal. Move that over twice, right? Or divide it by 100. And then time, of course, has to match. Now, compound interest, it is going to give you one of the pieces of information, what you put in, 1 plus because you're growing. Your rate is going to be per year usually, but compounded one of these. And if it's yearly, once a year. If it's weekly, 52 times per year. Monthly is 12 times per year. Quarterly is 4. Daily, we're going to use 365. One of those will be used for your N. And that N is there twice. Because your rate, since you're doing it 12 times, like monthly, 12 times a year, you're going to divide that rate by 12 for each time you do it. And then the 12 here, so if you did it for 1 year, that would be the 12 times 1, so 12 times per year. So don't forget that N is in there twice. And then finally, A equals PE to the RT power. E is a very special number. If you want E on the calculator, there's 2 places. And it will be on your calculator in Desmos. Yeah, I'm not going to show you this, but I'm looking at Desmos right now. So if you go to your scientific calculator in Desmos, you're going to find that E when you go over to your function button. Where we had the NPR and the NCR, there's an E there. There's also a natural log and a log. There's also just an E to the X button on there, which is the same thing. Your calculator, if you're using one of these, has second divide gives you just E, which is always, just like pi is always 3.14, E is Euler's number, and it's always 2.718. It's a constant. It's just a number. But since we raise E to the power a lot of times, you can do second, and over under ln, over here, is a E to the power. So E to the X, which you can type in the power, which is the same thing you have on Desmos. So if you want to use E to a power, then point whatever, you can raise to any power you want. Okay, so we'll use that in a minute, but so you have that E, which is the constant, and then your rate again still as a decimal, and your time. Excuse me. Okay, so let's just go over quickly a couple things. Here's your equation already set up for you. You have 980 times 0.85 to the t power. Does this represent growth or decay? Well, if this number is less than 1, any number less than 1, then that is going to be decay. If it's greater than 1, anything greater than 1, it's going to be growth. Shouldn't be 1, because 1 to any power is just 1. That's not growth or decay. That would just be a flat line. So what is the rate of growth or decay? That is what is the R value. So if you did 1 minus your rate, it gives you 0.85. So they're saying, what is that rate value that would make that true? Well, you can just switch those and do 1 minus 0.85. That'll be 0.15. So just remember, if you want a percentage, that's 15% when you move the decimal back over. So to get the rate of decay, just do 1 minus whatever value is inside there. The initial value is always this, what you put in. 980. I don't know if that's dollars, people, things, what it is, but. And then evaluate for t, so it'd be 980 times 0.85. T is 5, so to the 5th power. And then grab Desmos or your calculator, 980. Oh, not cosine. 980.85 to the 5th power. 434 point. Usually we're talking about money. Do 2 decimals for money, but we don't know if that's money. If that was things, items, people, bugs, something, whatever, then you wouldn't use a decimal at all. You just round to the nearest whole number. All right. So, second part of that, example 2, given this equation, 450, 1.12 to the t power, does this represent growth or decay? Well, that 1.12 is bigger, so that's growth. What is the rate of growth? Well, then that's also just 1.12 minus the 1. So what would you, because you know this is 1 plus r, so subtract 1 from that, and you're left with 0.12, which would be a 12% growth rate. Initial value, 450. And evaluate for t, so 450 to the 7th power. Just plug it in, 450 times 1.12 to the 7th power. Yeah, you can see those. So 994.81. And again, we don't know if that's money or what, so. All right, so growth, decay, just know the rate of growth is not, or the rate of decay is not going to be that 0.85. You have to get what's left from the 1. But when you have growth, you can look at just the decimal portion because you're taking away the 1. All right. So compound interest, we have compounding. You're going to deposit $1,000. The interest is 6.2%, and it's going to be compounded annually. And all I want for this is just write these functions. So compound interest says the amount you end up with will be what you put in, 1 plus your rate as a decimal. So 6.2, when you move that twice, would be 0.062. Or if you're not sure, or you want to just grab the calculator, do your percentage just like it looks and divide by 100. And that'll always give you the right decimal, so it'll be 0.062 over, and annually, if you look back at those, remember annually is 1, weekly 52 weeks in a year, 12 months in a year, 4 quarters in a year, and 365 days in a year. So weekly would be over 1 to the 1 times t power, because we don't know how many years, but t would be years. And this should say 6.2% yearly compounded this many times. So if it's compounded quarterly, 1,001 plus 0.062 over quarterly is 4. So this would be to the 4t power. So that goes twice, once for annually. Monthly, the amount out would be what you put in, 1 plus the rate divided by monthly is 12. to the 12t power. So it's going to happen 12 times a year. This one's going to happen 4 times a year. Weekly, 52 weeks in a year, so 1,001 plus 0.062 over 52, 52t power. And then if you had to evaluate, just plug in your t, just make sure that both of those numbers stay in the exponent. Remember, Desmos likes to kick things out of the exponent, so put parentheses when you're doing it in Desmos. Put parentheses around those so that it'll stay. All right. Example number 4, compounding continuously. The formula is P e to the RT power. So for this one, you would say A equals the amount you put in, 808. E is your base to the R, again, same percentage, so it'd be 0.062 times the number of years. And since that's in the exponent, put parentheses around that for Desmos. So to type that in, you can see the calculator. 808 second ln will give you e to the, and again, if you're doing Desmos, you're going to want to put parentheses around it, 0.062 times 8 power. So that'll end up with $1,326.85. Again, if it's money, 2 decimal places, just like money. Okay, so then you're going to be expected to do some just simple word problems with this compounding, or this growth and decay. The house value appreciates. This word is used a lot, and it stands for growth. Appreciates means it's going up, like ascend is going up. You can have words like increases, grows at a rate of, just anything that, but appreciates growth, right? 3.5% every year. How much will a $260,000 house be worth in 30 years? So this is your growth, right? Which is A equals P, 1 plus R to the T power. Well, the amount of the house will be worth, if it starts at $260,000, 1 plus your rate, to get to move it twice, 0.035 for 30 years, 30th power. So on your assignment, make sure you write out the formula, not just the answers. So if you miss a problem, you can see, did I do the formula right, or maybe I just typed it in my calculator wrong, maybe. So 260,001 plus 0.035 to the 30th power means it will be worth $729,766.36 in 30 years. All right. The value of a new car depreciates. You've probably heard that word before. That implies decay. So you could say they might use the word decay there. That decays at a rate of, it decreases. Anything implying going down, depreciates, you will use the decay formula. Just use minus. So how much will a $25,000 car be worth in 6 years? $25,000. 1 minus. Doesn't matter how many decimals are after when you move that over twice. It'll be 0.0935. Just include the whole number. And that's 6 years. Open up your Desmos. 25,001 minus for decay, 0.0935 to the 6th power. So the car is now worth $13,800 $872.25 after 6 years. All right, so growth and decay, not too bad with the word problems. There are a couple special cases, or a few different cases where it doesn't tell you the rate. It just says like a certain bacteria doubles, or they might say triples or quadruples. Of course, doubles is times 2, right? Triples would be times 3, quadruples times 4. Might say something about halves. If it halves, I can't spell that. That would be times a half, right? But when it doubles, then you are doing, the amount will be what you put in, and your base is just 2. You don't do 1 plus or anything for doubling or anything. So the growth rate for this is actually 100% growth rate. When something doubles, that means what you have, you get 100% of that again, and that's twice as much. But that's to the t power. Here, every hour. So now my t is hours, right? It's doubling every hour, so that t hours. So if there are 5 bacteria in a petri dish, and they are doubling every hour for 10 hours, then I can just do a 10 there. Now if this said for 1 day, I'd have to do a 24 there, because that's 24 hours. If it said for 2 days, I'd have to multiply 24, right? So make sure your time matches your time for your rate. So that would be 5 times 2 to the 10th power. There would be 5,120. Like I said, if you're talking about things, countable, measurable things, you can't round this number, or you don't round this one anyhow, but you would round that. All right. Number 8, you have Alan depositing $1,500 into an account that earns 5.25 annual interest, compounded monthly. So whenever you see that word compounded, that's when you know to use a compound formula. If it doesn't say compounded, you don't have to worry about that compound formula. So if you look, the formula is P1 plus R divided by N to the NT power. Put parentheses around that. So how much you put in, 1 plus your rate, which moved the decimal twice, is 0.0525 over monthly 12, and then times 12 and 8 years. 12 times 8. So remember, that N isn't going to be a number in here anywhere. It's always going to be given by whatever word it's being compounded. You don't have to put this in as a fraction. Now Desmos will change that straight to a fraction, but if you're using your regular calculator, remember it will divide before it adds for order of operations. So 1 plus 0.0525 divided by 12, to the parenthesis 12 times 8 power. So it's going to grow to $2,280.85. So there are a few of the compounding. Just especially pay attention to how many times it's being compounded. Look back at your formula. I believe, I'm not certain, but I believe this is all on your assignment sheet also to review. If not, you might have to come back and open the notes. They're right there below the video, or above the video. They're with the video. All right, example 9. Mice population, 8,500 mice. That's a lot of mice. And I'd have one happy snake. But is decreasing by 7% each month, right? Write and model this situation. So we have the amount is 1, it's decreasing minus, right, your rate to the t power, where that needs to be months. So you're starting with 8,500 minus 1 minus 7% is 0.07. And it tells us 3 years. Well, to get months out of 3 years, you would multiply it times 12, right? Because there are 12 months per year. So, like your time, there are more months in 3 years, right? That's a multiply. If this was per year and it told me how many months, then we'd have to divide that out. But make sure that you match up those. So watch out for those problems. Double check your rate. If it doesn't say each month, you can assume that the rate and the time match each other. But be careful if they don't. 85,000. 1 minus, decreasing, right? 0.07 to the parentheses 3 times, that's not 3 point, that is 3 times 12. So there would be 623 mice left. And you would round that because we're talking about mice, so you don't want partial pieces of mice. All right, the number of mosquitoes at the beach is increasing at a rate of 21% weekly. 21% weekly. 2,500 mosquitoes today. How many will there be in 3 days? So weekly to days, that's different. So again, it's increasing. So we do the A equals the amount you started with, 25,000 mosquitoes. 1 plus 21%, move it twice, is 0.21. And here, if I want days to weeks, right, that's a division problem. 7 days makes 1 week. So if I had 7, I would divide by 7 and get it. So now we have 3. So however many days you divide out 7. So that would be your power. So if you're going from days, which are a shorter amount of time, and you need it in weeks, that's division. So you can see the calculator. I'm going to do 2,500 mosquitoes. They're going to increase 0.21. Oh, that's a large increase. And then parentheses 3 divided by 7. Phew, my phone is just going off too much. Sorry about that. So even though that's a large rate of increase, it hasn't even been a week. So they won't even increase 21%. So they would increase 21% in a week. And that ends in 3 if you round it right. All right. So then the last part of your assignment is looking at what we're just talking about here, where when you look at a function, can you identify all the parts of it based on this sentence? You're going to have a few of these. So this function is, in your first blank, is whether it is increasing, decreasing, growing, or decaying, right? So I'm going to put growing. It's not decreasing, or increasing, right? Exponentially at a rate of, and that's that growth rate. So remember, you have to take out the 1 if it's above 1, because it's growing, it's above 1. So that's a 34 when I move that decimal. 0.34 is 34%. Every, and this is the part, so this is for if t is years, right? and I'm multiplying that times 12, then what value am I actually putting for my time? Right? If you take years and multiply them by 12, then you are changing them to months. So, right, because if I did 1 in for my years, my answer would be 12. Well, 1 year is 12 what? 12 months. So, look at the second one. So think about it this way. If you're multiplying, if I do years divided by that 12, that's a month, right? 1 year divided by 12. So if you multiply here, you can divide it out, and that'll tell you your rate. I didn't show that. Okay, if you do your 1 year and divide that out, if it's a multiply, just divide, do the opposite, and you know that's months. 1 year divided into 12 parts is a month. So in the next one, you have 1.05, so this one is also growing. If it was less than, you would say it's decaying. The rate is, take off the 1, so that is 5%, and it's in minutes. The t is minutes, and you're dividing them by 60. Well, what is 1 minute divided into 60 parts? Or think about it this way. If you take 1 minute, right, and multiply by 60, you get what? What's right? So think about it this way. If you match that number, right? If t is 60 divided by 60, you get 1. Well, that's minutes. So if I did 60 minutes divided by 60, I would get 1 hour, right? Or there are 60 minutes in an hour. So remember, if you're multiplying, then if your t is years, this value is going to be something smaller than years. But if you're doing t divided by 60, then if you take your minutes and multiply them by 60, you're going to get a unit that's larger than minutes. So look at those, and for the most part, like I was saying, what's a year divided by 12? If this is a multiply operation, do the inverse. What's a year divided by 12? That's a month. Down here, what's a minute times 60? Well, that's an hour, right? All right. So that's it. That should get you started on that assignment. Have a great day, and I will talk to you soon.